Which of the following molecules would experience only London dispersion forces between its own molecules? H2, CH3Cl, H2O, or NH3? The answer is H2, hydrogen, because all of the other molecules are polar, meaning they can form permanent dipole-dipole interactions between themselves. But because H2 is nonpolar, it can only form London dispersion forces. A gas mixture contains 2 moles of helium and 1 mole of argon. Which statement is true? Helium and argon have equal partial pressures because they are both gases. Argon exerts 2/3 of the total pressure. The partial pressure of each gas depends only on its molar mass. The partial pressure of helium is 2/3 of the total pressure. The answer is the partial pressure of helium is 2/3 of the total pressure, because the partial pressure of a gas equals its mole fraction times the total pressure. Well, the mole fraction of helium is going to be 2 divided by 3, because there's 2 moles of helium but 3 moles of gas in total, meaning the partial pressure of helium is 2/3 of the total pressure. Solvent particles clustering around solute particles in a diagram shows ion dipole interactions, precipitation, evaporation, or freezing. The answer is ion dipole interactions, because dipoles from solvent molecules will arrange themselves to be attracted to oppositely charged ions from the solute and surround them, enabling them to remain dissolved in the solvent and move freely within it. An amorphous solid differs from a crystalline solid because its particles are arranged in a regular geometric lattice, its particles have random orientation and no long-range order, it is always metallic, or it is composed of only ionic bonds. The answer is its particles have random orientation and no long-range order, because in a crystalline solid, all ions are regularly arranged in a regular repeating lattice, but in an amorphous solid, there is no regular repeating structure. However, it is still a solid overall. Ultraviolet radiation corresponds to which type of transition? Rotational, vibrational, electronic, or translational? The answer is electronic, with rotational transitions corresponding to microwave radiation, vibrational transitions corresponding to infrared radiation, and electronic transitions corresponding to ultraviolet radiation. A Maxwell-Boltzmann distribution becomes broader and flatter when temperature decreases, temperature increases, volume is reduced, or when the gas becomes denser. The answer is when the temperature increases. Which compound is most soluble in water? CH4, CF4, NH3, C6, H6. The answer is NH3, ammonia, because ammonia is the only molecule out of the options here that can form hydrogen bonds. And hydrogen bonding between the ammonia and water molecules enables them to mix uniformly. A solution is diluted from 2 molar to 0.5 molar. If the final volume is 400 milliliters, what was the initial volume? 25 milliliters, 50 milliliters, 100 milliliters, or 200 milliliters? The answer is 100 milliliters, because the final concentration is 4 times smaller than the starting concentration, which means the original volume must have been 4 times smaller than the final volume. According to Beer-Lambert law, absorbance increases when path length decreases, concentration increases, molar absorptivity decreases, or wavelength increases. The answer is concentration increases, because remember the Beer-Lambert law links absorbance of light to the concentration of a substance in solution, with absorbance equal in molar absorptivity multiplied by path length multiplied by concentration. So the greater the concentration, the greater the absorbance overall. Which phase change involves complete overcoming of intermolecular forces? Melting, freezing, vaporization, or condensation? The answer is vaporization, because if you completely overcome all intermolecular forces, no intermolecular forces remain between particles, which means they must be a gas, and vaporization is the only phase change here that would produce a gas. Light of which wavelength corresponds to highest energy? 750 nanometers, 500 nanometers, 250 nanometers, 1500 nanometers. The answer is 250 nanometers, because remember, the shorter the wavelength of electromagnetic radiation, the higher its frequency and the higher its energy. Which gas would deviate the least from ideal behavior? NH3, HCl, CO2, or He? The answer is He, helium. Because helium gas is comprised of individual atoms, it's monatomic, and the strength of intermolecular forces between them are very small, compared to all the others which have stronger intermolecular forces. The stronger the intermolecular forces between the gas molecules, the more the gas deviates from ideal behavior. Because for an ideal gas, we assume no attractive forces between molecules. A liquid with weak intermolecular forces will have a low vapor pressure, a high vapor pressure, a very high boiling point, or no interactions with itself. The answer is a high vapor pressure, because if there are weak intermolecular forces between the particles, it is easier for particles at the surface of the liquid to escape and turn into vapor. Microwave radiation causes molecules to undergo transitions in electronic energy, intermolecular energy, rotational energy, or nuclear energy. The answer is rotational energy, and this is why microwave radiation is used in microwave rotational spectroscopy. According to the ideal gas model, gas particles strongly attract one another at all distances, occupy significant volume relative to the container, undergo perfectly elastic collisions, or lose kinetic energy with each collision. The answer is they undergo perfectly elastic collisions. This is one of the key assumptions of the ideal gas model.